In this video I'm going to show you how to conduct statistical analysis using SPSS. So basically in this video I will do a full project. Okay, so this is the instruction file. Basically which variable have to conduct, have to consider, and what does it mean by specific variables or columns name, how it is denoting. Okay, so this is the instruction and this is the data file. So first of all I'm going to read the whole thing. The project aims to study the determinants of annual wages in the US in the year 2000. So this is the age column, and you are presented with the data referring to early middle age individual 35 to 45 years old. So this is the age variable, and the data set consists of 10 variables. There are 10 variables containing information for each individual, and in particular there are 5 quantitative variables and annual wages, number of previous jobs, experience, number of children, and age. And the rest of the qualitative variables: white, married, college, full time, and gender. Okay, gender. So the thing is that the variables are following: age, the age indicating the variable indicate the ages of individual; number of children, the variables indicate the number of children of under the age of 15 that the individual has; number of jobs. Okay, so wages, this variable indicates the annual wage of the individual; experience of week, this variable indicates the previous experience of individual; the total number of paid work weeks. Okay, the gender, 1 indicating the female, 0 indicating the male; full time, 1 indicating the full time employee, and 0 indicating the otherwise or part time employee; college, 1 indicating the college and more, 0 indicating the otherwise; married, 1 indicating married, and 0 indicating the unmarried or divorced or a widow; white, 1 indicating white and 0 indicating non-white or others. So this is the text guidelines, what actually I have to do here. So first of all I will do descriptive statistics for the whole sample, as well as specifically male versus females, white versus non-whites, and married versus non-married. Okay, so here I will do whole descriptive statistics for numerical variables and qualitative variables also. After then I have to do the comparison between the average wages for the whole sample, only females, only males, and the US average. Okay, the assume that the US population average yearly wage is $60,922.73, and the population yearly wages for females is $40,163.55, and for males 90,370.86. Okay, so after then I have to conduct a multiple linear regression. So let's get started. Okay, so first of all I have to import the Excel dataset into our SPSS. So first of all I have to open the SPSS program. Okay, SPSS. Okay, I have to import the data file. Import the data file, Excel formatted. Here I already put everything in desktop, so that's why I just open the desktop file. Okay, So here already imported the data file, but now I have to code the meaning of each things, like the zero means male and one male means female. Okay, so first of all, I'm just coding the variables. Okay, what does mean white? One means, sorry, one means white, zero means non-hot. Okay, and married, one means married, zero means otherwise. Okay, and college, one means college or more, zero means otherwise. Okay, and gender, one means zero means full-time, one means employee, zero means okay. So I have done the coding. So now I have to conduct the analysis. First of all, I have to conduct the descriptive statistics for the whole sample, whole data. So descriptive statistics is two types, basically frequency for qualitative variables and descriptive for our quantitative variables. So I have to do two things here. So first of all, frequency for qualitative variables, white, married variables, college variables, full time, and the number of children, and sorry, number of females, not number of children. Okay, so I have done the thing have to do, like I can show the chart also. So that's why I am using bar chart here, so which basically help me to find out the thing here easily, visualize the frequency. Okay, so I can use the data labels also here, right? Double click right button, sorry, here right button, show data labels. So data labels is basically two types you can use, like count and percentage, also then custom, I mean level position, then custom. Okay, that's fine. So I can do these for all graph here. Okay, so one by one you can do. So then I'm doing the number of children is numeric scale. Okay, numeric. So then I have to do descriptive statistics for our quantitative variables, number of jobs, experience weeks, number of children, and age. Okay, this is our descriptive statistics, which actually showing the mean value, maximum, minimum, standard deviation. So you can use other things also, like mm, you can use options like variance, range, kurtosis, skewness, uh, which actually help you to understand the variation of data, like symmetrical or asymmetrical, so data normally distributed or not, which basically showing the kurtosis and skewness also. So you can use it here. I just use four things: minimum, maximum, mean, and standard deviation. So mean indicating the average value of the things like wages, number of jobs, average. Mean indicating the average. Standard deviation is the average thing of how the distance between the mean value. Okay, how individual value distance from the mean value. Okay, and same thing goes to all. Then I have to conduct one sample t-test for all values, and only females and only males also. So here already showing the uh, threshold value or standard value, like how much they are spending wages for whole the US population. So 60,922.73 for all, and females 40,163.55 dollars, and males 19,370.86 dollars. Okay, so first of all I am conducting one sample t-test for the whole data. Okay, then one compare means one sample t-test, then wages our test variables, and our value is like 60,000 9 60,922 point, sorry, $0.73. Okay, so this is the output here. So one sample t-test basically help us to find out the is there any significant difference between the standard value to our whole value. Okay, so here the average value is 16,000 16,080 875.60. So on the other hand, our standard value is our threshold value is 16,922.73. So we can decide our decision, or we can take our decision based on the significance value. Here the significance value is 0.850, which is greater than 0.50, 0.05. So as the value is greater than 0.05, so we cannot reject the null hypothesis. The mean value is equal to our standard value. So okay, so the test value, like our mean value for all samples is equal to our uh, our test value. Okay, we can take the decision here. We cannot reject the null hypothesis. When the significance value is less than 0.05, then we can reject the null hypothesis. That means that would be like the mean value and the test value is significantly different for each others. So on the other hand, I can do same thing for male and females. So first of all we have to select case our data. So how I can select case only for males and females. So here if condition satisfied, then I have to use if condition. Females equal to 1, indicating females. So first of all I am conducting females, I'm selecting the females, and analyze compare means one sample. So wages for females we know 40,000 14,163 $14,163.55. Okay, the same thing goes to here the significance value is 0.60, which is greater than 0.05. That means the overall females have wages mean values is same to our test value. There is no significant difference between the mean value and the test value. That means we cannot reject the null hypothesis. Our null hypothesis indicating the mean value and the test value is equal. Okay, our alternative indicating that the mean value and the test value is not equal. Then I have to conduct the same thing. Select case where 0 indicating the male. Then okay, now I can conduct analyze compare means and one sample detection. For males the value is 19,086 and 370.86. Our here the significance value is 0.493, which is greater than 0.05. That means we cannot reject the null hypothesis. If I say in other format like we fail to reject the null hypothesis. Okay. The main value is 19,109.5246. On the other hand, our test value was is 19,370.86. So there is no significant difference between the mean and the test value. Okay, so now I have to conduct the multiple linear regression based on our variables. Okay, so test variable annual wages is our dependent variables. On the other hand, our independent variables is gender, ethnicity, and education, experience, and the total number of children. Okay, so there are the assume thing here we can compare based on our result. So first of all I have to conduct the multiple linear regression. First of all here I have to omit the select case because now I am doing the for all. Okay, that's why first of all I just omit the select case. Then I am conducting the multiple linear regression. Here our dependent variable is wages, and on the other hand our independent variable is our female, indicating the gender, and ethnicity basically white, indicating the ethnicity, and education, experience, and number of education, college, indicating the education, experience, and number of children indicating. Okay, so there are five things. Confidence levels 95%. Okay, plot no use plot. Then standardized and unstandardized predicted values, and then the okay. Here the model summary indicating the R value, which is correlation value, and R square value, which indicating the how much all the variables basically explain the dependent variables. So here the correlation value is 0.45, which is indicating the moderate correlation between the dependent and independent variables. On the other hand, all the independent variables can explain 20.3% on the dependent variables, and the rest of the part is um, otherwise others, okay, unexplained. Here we can see the constant value is like 6,434 4.773, and the females indicating minus 3,764.658, which indicating that they are earning less than males. They are earning less than males. How much they are earning less than males? How much they are earning less than 3,764 dollars, $64.65. On the other hand, white people are earning 60 1,605 $50.58 more than the non-white people. On the other hand, those are college and more. They are earning one 61.68 dollars more than our otherwise values, like otherwise values. On experience of weeks basically indicating how much increasing one unit, when if the experience increasing 1 weeks, then the wages increase $12.14. Number of children, if the number of children increase 1, then our wages value increase 608.006 dollars. So this is the explanation. You can explain the coefficient values here. When everything is here 0, then the constant value is 6,434.77 dollars. So this is the explanation you can use. And our here the in the ANOVA table you can see the value is 0.00. That means our independent variable are reliably predict the dependent variables, okay. This is the explanation you can use, okay. Thank you very much. This is the whole thing. I just explain how to conduct in SPSS program. If you think that this is helpful for you, you can follow my page and follow my YouTube channel also. Thank you very much.